sums of geometric sequences are what we're going to be studying next. And what we find out is that the sum of the first n terms of a geometric sequence is called an nth partial sum, just like before. But this one is denoted as S sub n equals the first term, a sub 1, times the quantity of 1 minus the common ratio to the nth power, the number of terms power. And all of that divided by 1 minus the common ratio, as long as r does not equal 1. So let's go ahead and try an example out with this one. Let's go ahead and find the sum of the first 6 terms. If the first term, a sub 1, equals 1, and the common ratio is 2. So again, we know that's our geometric sequence we have written up at the top here. Here are the first 6 terms. I'll bet you can add those up to figure out what they are, but of course this works for when it's a lot more numbers and they're fractions and decimals and things like that. So as we go ahead and plug this in, here's what we're going to get. So let's see. We're going to go ahead and have the sum of the first 6 is equal to the first term 1 times 1 minus the common ratio of 2 to the n power, the 6th power. All that's going to be divided by 1 minus the r, which is the common ratio of 2. So as we simplify this, we're going to get 1 times 1 minus 2 to the 6th power is 64. All divided by 1 minus 2 is negative 1. So notice here 1 minus 64 is negative 63 times 1 is negative 63 over negative 1. And we get a sum of the positive, as we expected, 63. That's equal to the sum of the first 6 numbers. Okay, so then what we can do, let's take a look at what happens if we have a different sequence. So let's this time find, again, let's do the sum of the first 6 so we can count it out if we need to. But this time, let's say if we have the sequence negative 800, comma, 400, comma, negative 200, comma, dot, dot, dot. I'm not going to write out the other 3 because we have really all that we need here. We need to find, if we look up here, we need to know the first term, which we see right there, negative 800. We need to know the common ratio, which 400 divided by negative 800 would be negative half, or negative 200 divided by 400 would be negative half. So let's go ahead and write all this in. We know that the first term is negative 800. We know that the common ratio this time is negative 1/2. It's a fraction. That's okay. And we know from right here, S sub 6, we're looking for the 6th term. So n is a 6. So when we go ahead and plug that in, what we're going to go ahead and get is the sum of the first 6 terms is equal to the first term, negative 800, times 1 minus the ratio, which is negative 1/2, to the, gosh, what are we looking for here? We're looking for the 6th power. And all of that is going to be over 1 minus negative half. So, as we start to simplify this, what we get, let's see, let's leave that negative 800 still, times, now, gosh, if we do negative 1/2 to the 6th power, which we have to do the order of operations first. We know negative to an even power is going to be a positive number still. Negative 1 to the 6th power is still going to be 1. 2 to the 6th power is 64. So we really have 1 minus 1/64 right there. All divided by 1 minus a negative half. That's really going to be 1 plus a half. So let's call that 3/2. Okay. So let's see. Let's keep simplifying over here. I'm going to go ahead and continue on down here. Let's go ahead and move over here a little bit. So we still have our negative 800 times 1 minus 1/64 is going to leave us with 63/64. All that divided by our 3/2. Of course, we can put this in our calculator anytime now. And if we actually simplify it out, believe it or not, we end up with, I want to go ahead and remind you how the rest of this goes, is we just multiply by the reciprocal here, right? So we have negative 800 times 63/64 times the reciprocal of the denominator. So that's going to be 2/3. And so really, check this out. We can do a lot of cross-canceling here. 2 goes into 64 32 times. 3 goes into 63 21 times. And we can go ahead and multiply all that out. And we end up with negative 525. That's the sum of the first 6 terms. So we've got that. Now the last thing I'd like to show you is that we could actually use summation notation to solve the same problem here. So we could look at this as the sum of n equaling 1 to 6 of 1,600 times negative 1/2 to the n power. Now we could go ahead and multiply that all the way out, and we could do the summation for it. We'd get 1,600 times negative 1/2 to the first power plus 1,600 times negative 1/2 to the second power plus doddly 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 dot. We got to keep going. 1,600 times negative 1/2 all the way to the 6th power, right? We'd have to multiply all that out. Well, what we can do is we can just simply get this value right here, which gives us our first term. And you'll notice what that gives us is negative 800. If we do the second term here, we find that we get 400. If we do the third term, we get negative 200. We start seeing this pattern here that we had started with. Well, if we do this divided by that, we get the common ratio r, negative 1/2. Right here is the first term, a sub 1. And what else do we need? We need to know the 6 terms. Right there is how many terms. From 1 to 6, we're doing 6 terms. So we would then know n equals 6. So we could plug all of that into the same formula just like we did right here. And it would simplify out exactly the same way, getting to the exact same answer, showing us that the summation here also equals negative 525. So I hope this helps out some more folks. We've got one more video with a little bit more to go. Keep with it. You're learning strong. Talk to you soon. Bye.